Alright, so I've got multiple versions of this first one. I'll show you a couple different ways to do this. So one way is I could draw a straight line down this point. I know it looks a little curvy, but get the idea that it's straight line. So that splits it into two rectangles. Whereas this one is a 13 centimeter by 6 centimeter, and this one's a 5 centimeter by 4 centimeter. So if I do 16 centimeters times 6 centimeters, and then I'm going to add that 5 centimeters by 4 centimeters, I get 78 square centimeters plus 20 square centimeters, and that gives me 98 square centimeters. A second way I could have done it is I could have done it with a horizontal line, where this is 13 by 2 and this is 18 by 4. So here I have 13 centimeters by 2 centimeters plus 18 centimeters by 4 centimeters. Then I have 26 square centimeters. And here I have 72 square centimeters. And again, 98 square centimeters. Two different ways, perfectly fine. You choose the way that works for you. I'm going to show you even more ways I could have done this. So yet another way that this could have been done is the idea that I could have said, hey, I want to complete the rectangle. And if I look at what the rectangle is, so here if I look, I can start with the large rectangle. So the large rectangle is 6 centimeters by 18 centimeters. So I would be doing the 6 centimeters by the 18 centimeters, but that's if everything in that rectangle is filled in, which is not. So then I have to say, well, I've got this little rectangle that's actually been removed. So even though additivity, we think about adding the different parts, we can also subtract a piece. So I could say minus 2 centimeters by 5 centimeters. I'm going to remove that small rectangle. So if I do this, I have 108 square centimeters minus 10 square centimeters, which is 98 square centimeters. Now, we often think about always doing these as if they were split into easy looking rectangles, or maybe as we get later, triangles as well. But I want to show you that you can even do this with some other more complex shapes like trapezoids. So if I draw the diagonal down here, I have a trapezoid where here are my two bases, and I have a trapezoid, I'm going to change the color, where here are my two bases. Now the formula of a trapezoid, you probably haven't thought about in a while, but it's 1/2 base 1 plus base 2 times the height. So we just got to pay attention to what is our height. And our height is the segment that connects our two bases, which in that top trapezoid would be the 13 centimeters, and on the bottom trapezoid would be the 4 centimeters. So I'll start with the first one. So I may have to do these one line at a time. So I'm going to call this one number 1, and I'm going to call this number 2. So the area of 1 is going to equal 1/2. Base 1, we'll call the 6 centimeters, plus base 2, we'll call it 2 centimeters, times the height, and again that's the piece that connects our two bases, it's 13 centimeters. So here I'm looking at 1/2 of 8 times 13, and then 4 times 13 is 52 square centimeters. Try and keep those units. So now let's look at the area of the second one. Oh, change our colors here. So again, it's 1/2 base 1, so there's my 18 centimeters, plus base 2, which is 5 centimeters, times my height, connecting my two bases here, it's 4 centimeters. Now, when I add 8 plus 5, that gives me 23. Kind of hard to take the half, but remember that multiplication is commutative, so I know that I could do 23, and then I could take 1/2 times 4, and that's 2, and then this will give me 23 times 2, which is 46 square centimeters. And if I think about that, 46 plus 52, so I'm going to do this to the side. 46 plus 52, 6 plus 2, 8, 4 plus 5, 9. So if I add those two areas together, I still get the 98 square centimeters. So there's a lot of different ways that this can be done. Now with the flag, what I can do here, and I'll use the, I'm going to use an actual tool. Say that I look and say, oh, I can't deal with the curves, but what if I draw straight lines across? What do I notice happens? What I notice happens is, in essence, I have these boxes where I can take my bottom piece here and shift it right here and shade this in. And take this piece, shift it to that little curve, and what I really have is this rectangle. And that's very easy to find, because that's 5 inches by 3 inches, which is 15 square inches. Much, much simpler. Now, like I said before, when you get some of these problems, instead of adding using the additivity, we subtract. Because here, I have the large rectangle, and I don't need that small dark gray rectangle in the middle. So here what I do is that my area is my large minus my small. And I'm going to take this, move it over a little bit, give me a little bit more room. So that would be a 12 foot by 10 foot area minus the 8 feet by 4.5 feet. That subtracts out that one little piece there. So I have 120 square feet minus 36 square feet. And when I subtract them, I end up at 84 square feet. Nope, forgot to put my square up there. So 84 square feet are in the light area, and the other 36 square feet are in that dark shaded area. Alright, so here we get a little bit more complex, because we don't have all the measurements like we do in the others. So we got to either cut out the small parts that are missing and look at the large rectangle, or we need to split it into 3 small rectangles. Either way, it's going to take a little bit of time, a little bit of effort, and you just got to go just short amounts of time. So, one thing we have to realize is exactly how long is one single side. And if I look at this entire side, that's the 15 and the 2, and that's 17 inches for that entire length. Which means that if I look at this side, this has to be 17 inches as well, which means that this would have to be a 9-inch side. That's the first thing I have to recognize. So let's just go in and fill in all those missing pieces, and this will make it a lot easier. So I'm going to erase this out. Now if I look at the other one, if I look at this entire length, I can tell that that's 9 inches, which means if this one's 2 inches, this would have to be 7 inches. So here I have the rest of my measurements, and now it will be a little bit easier to try to put everything together. So I can draw my lines in wherever I want, as long as it makes shapes that are easy for us to find. So I could do these 3 rectangles, whereas this is a 2 by 6, and I know that this one is 8 by 7, but then I've got this really funny one here, and I'd have to figure out, well, why do I say this is funny? So I'm going to move that out of the way. So I know this entire piece is 9 inches, but this is 2 inches, which means that this piece would have to be 7 inches. And why does that matter? Well, this rectangle, here's 7 inches, is a 7 inch by, well, then I've got this entire length right here, which we said was 9 inches. So it's a little bit different way of trying to put that middle one together. So when I look at what all do I have 8 inches by 7 inches plus 7 inches by 9 inches plus 2 inches by 6 inches. So here we have 56 square inches plus 63 square inches plus 12 square inches. Okay, so then we can add all those values together, and that would tell us that this is 131 square inches. Now I'm going to show you one other way that this could be done. I'm going to erase everything, get it out of the way, show you one other way we could have done this. So we know that we're trying to get to 131 square inches. As I said before, we could always use the idea of the big rectangle minus the little rectangles that aren't part of the image. Because here, we know this is 6 square inches because it's a 3 by 2. And we know this is 16 square inches because that's the 2 by 8. So what we'd have to pay attention to, well, this entire length is 9 inches. This entire length is 17 inches. So we know that one of the ways we can find area is to do the big rectangle minus the small pieces that are missing. So that would be a 17 inch by 9 inch rectangle minus the little square, which was 6 square inches, minus the 16 square inches. So 17 times 9 is 153 square inches. And then we're subtracting, really, you guys subtract 22 square inches. And 153 minus 22 is 131 square inches. So whether I split it up into small rectangles and add the 3 values together, or I take the large rectangle and subtract out the pieces that don't exist in the image, it'll give me the same solution in the end.